Great. Good afternoon, everyone, and welcome to tonight's technical meeting by AACE International Section. My name is Fran Vera, and I will be your host for today. It is wonderful to have attendees from all over Australia and many other countries. Today, our webinar is focused on how to manage complexity in capital projects. Before getting started, I'm going to introduce Paul Harris. He's our president, and he will run some slides regarding the AACE International, and he will introduce our presenter tonight.
Thank you very much, Frank. Good day, my name is Paul Harris. I'm president of AACE Australian Section, and this is the technical meeting 22nd of October 2020. So first of all, our agenda, I'll talk a little bit about meeting procedures, introduce you to AACE International and AACE Australian Section for those who are not members. I'm going to talk about each week. I talk a little bit about the website, and I'll show you a couple of things on the AACE International website. Then we got a webinar on how to manage complexity in capital projects. I'll hand over to Matthew, and then we'll have questions to the speaker at the end, and then we'll have an open mic session where anybody can talk to anybody at the end of it and have a discussion. So first of all, attendees, you'll all be muted during presentations. You'll have an opportunity to interact at key points in the presentation. I think actually it's only going to be at the end. Some presenters like to take questions in the middle, but I think Matt will wait till the end. If you want to ask a question, please type your question in the chat feature, and then what will happen is that Frank will read the question out as if you were asking the question and allow Matthew to answer it. We'll make this session available, this webinar session available on the AACE Australian YouTube channel after this session, and we'll put it in the newsletter and on our website. If you wish to have a certificate of attendance, please email info@aace.org.au, and Frank will provide you with a certificate of attendance. So let's talk a little bit about AACE. AACE stands for the Association for the Advancement of Cost Engineering, and it serves total cost management computers since 1956. It used to be called the American Association of Cost Engineering, but they decided to go international, so they've called themselves Association for the Advancement of Cost Engineering now. It's committed to constructive exchange of ideas between members, which is what we're trying to foster here. Development of technical guidance and quality education, again, that's what this presentation will serve as, and recognition of subject matter experts. The committee that run AACE Australian Section, so AACE Australian Section is part of Region 8, which includes countries like India and China and Malaysia, New Zealand, and basically the Far East and Pacific area. We've got in Victoria, we've got the bulk of the members. We've got myself as president, Yazid is a treasurer, Russell's recently joined us as training development coordinator. We've got Raf Dure looking after the Victorian region and sponsorship. Cameron's doing a great job on the website and social media. Membership secretary, I should have filled that in, and we've actually got a new membership secretary, Salam, so I'll fill that in. My apologies if he's listening. We got Frank, who introduced us, and also we got publications coordinator Keith Farrell. In Queensland, we got Lou and Soleil, and then we've got Karen, the secretary here. So yeah, so I see what I've done. I put Soleil up there, and I should have moved him from here, so I'll do that next time. So I want to draw your attention to part of the AACE website. So if you go to AACE, which is aace.org, and go to continue education modules here, what you'll find in the continuing education module is you'll have access to online professional development and training on a variety of topics which are recorded from conferences and also total cost management today webinars. So they're recordings that you can look at. Each session is about an hour in length and is worth one CEU, continuing education unit. You may view this session as often as you like and pause it and start again. So if you go to this particular part of the website, you'll see here, and then you can search through that part of the website. So if you're interested in learning more about some cost engineering subjects, you might want to have a look at this option. AACE International Headquarters, that's their website, and that's where you get information from them. And this is our website, and our Australian section is here. So speaker information, I'd like to welcome Matthew Winchur to present how to manage complexity in capital projects. This presentation investigates how the academic field of complexity can be practically applied to large capital projects. So Matthew, there's a great picture of him. He works for Lendlease. He's the development portfolio manager of operational assurance and performance. He's worked in a diverse cultures and sectors. He's born in Canada, where he started his own biotech in Canada. He's worked for Toyota. He now calls Australian home with experience in rolling stock, construction and civil sectors. And so I would like to now hand over to Matthew. So I'm going to stop sharing now and allow Matthew to share his screen.
Thank you for that great introduction. So you should be able to see my screen now.
Yeah.
Excellent.
Absolutely.
All right. So yeah, what I'm going to go through over the next little while is, if we can mute everybody, thank you. It's just go over some background and context around complexity, what it really means, you know, how we're seeing it every day, go through some basics of how we define it, and then apply those basics to capital projects, and then from that get a view of how to actually create a response, a practical response to complexity. A quick note on decision timing, and then some final thoughts. So starting off, just background. You know, every consulting company has put forward some stats on project success rates. Part of my role has been to identify problem projects before they occur. And I do this through you know, system of metrics, lead indicators, a robust review process. And over the past few years, when conducting root cause analysis of underperformance, more and more frequently, complexity has been raised as a cause of this underperformance. When I ask further questions, you know, to try and get down to what's really happening, it's been very difficult to identify how to improve the governance system. You know, and this is what started my journey. So basically, this presentation is a summary of part of that journey that I'm going to share with you. So first, let's build this up from a project level onwards. And this is a basic summarized view, simplistic view of a project environment. You know, you've got customer, you've got lots of different requirements that come in from the budget, the brief, the timing constraints, the contract constraints, the public from federal to state, different regulators. All these things drive the requirements of the project. Then you try to create a design which feeds into procedures, and then you actually have to figure out how to build or whatever you're going to do. So each one of these areas has their own ways of working, their own requirements, and the art of project management is usually getting these different components of a project to speak to each other and be coordinated. From there, we go to the business environment. So projects usually sit within the context of a business, and more value is being driven from intangible assets. So things you can't touch, such as design, data, networks, and less from tangible things like machinery, fleet, office equipment. So when a machine breaks down, it's easy to see when that occurred and to forecast the impact that it'll have. With intangibles, it's more difficult. So it's, you know, when you start to say, well, when is the point where a team starts to underperform, it's very difficult to pinpoint that moment in time. So then going to a larger level again, we go to a digital world, or a digital twin, as a lot of people are calling it now. So you've probably heard the term a smart building or a smart city. So this usually involves a digital twin. And a digital twin is when you integrate sensor data with digital representations of the physical world. And that digital world, usually starts off with structures. And in the world of building information management, that we call it 3D, 4D, 5D BIM, there are land attributes, civil infrastructure, social infrastructure, and then social dynamics, all different layers of data that can be in context for any piece of information that you may have. So coming back to sort of the project level, one of the ways that we're trying to manage our complex environments is through digital engineering. And that's a collaborative way of working using digital processes to enable more productive methods of planning, designing, constructing, operating, and maintaining assets. And it really does allow us to leverage technology and how we manage those tasks. The types of technology that we can leverage is always growing. So you have geographic information systems, which gives context to data layers, that Internet of Things, big data that's coming through, automated data capture, blockchain around instant transactions, photogrammetry, machine learning is a real buzzword at the moment. And the issue is that any one of these is a significant change that needs to be managed in an organization, but many of us are trying to catch up and implement many at the same time. So how that sort of affects, again, that project level of complexity. So you may have a digital engineer or an engineer trying to provide input into a digital model, a design model. And that digital engineering, it helps link in those changes, what's happening to the many aspects through some cloud-based application. And the risk is that this, say, structural engineer creating a change may not have the wherewithal of the impacts that's having across many other aspects of the project. So change with, say, a little cost impact could still require sourcing from, say, a different supplier, which would then dramatically push out the schedule. And many people, many users, all inputting into that central environment creates another level of complexity. So we need to sort of extend our way of managing complexity into this space as well. So with that sort of context in mind and that background, let's dive into complexity and how we can manage it. So this is the Sinefin framework. It is a way of sort of separating complex environments from other types of environments. So David Snowden put this together to help managers identify different situations and make sense of behaviors in those situations. So just going around, starting with simple, that's the domain of standard operating procedures. It's best practice. Complicated, those are situations where experts are needed to interpret the best approach. Complex, those are likely, situations on large complex projects, and we'll obviously discuss that a lot more. Chaotic situations are novel environments that need authoritarian leadership to sort of drive a way forward. And that disorder in the middle is just when you're not in any other situation. So one aspect I like about this this framework is that it really it helps highlight biases that one might have from stepping from one of those environments to another. For example, somebody who's been working in a complicated environment, such as a bureaucratic public company, will tend to see problems as a failure to provide experts with the time and information needed for analysis. So compare that to a complex environment. So somebody stepping into that environment that has continually changing environment, that same behavior would create analysis paralysis. So now that we can sort of recognize a complex environment from others, let's kind of move on to that main question. So that's, how can the term complexity be broken down and into a useful set of attributes? So the term complexity can mean different things depending on the situation. This is the way that I've broken it down. So starting on the sort of that top left, that structural complexity. So that is difficulty in managing and monitoring many different interconnected tasks and activities. Technical complexity, that's unique design challenges or techniques without precedent. Directional complexity, those are politics, misaligned goals, poor project definition. And process time complexity, the shifting environment conditions outside of the control of the project team. And that's a good example of that is COVID. So this framework, the reason I chose it was it helps link complexity to the decision-making needed to manage it. So just to give an example of that, a large-scale project with a lot of politics may require an executive sponsor as a response, while a small project with technical challenges may require some support from a chief engineer. Without this categorization, you might have your project chief engineer trying to manage politics with a client, which something that you don't want. So that's why this helps. So let's map these 4 aspects onto a simple project life cycle. So this is just a conceptual life cycle by project effort in the space that I work in, development and construction. And those phases that are there, so development, that's usually your master planning, massing, et cetera, approvals for development approvals, et cetera. The design phase would include things like product design, a lot of planning, and risk and opportunity balancing. Construction is more that disciplined delivery, higher focus on safety, and then commissioning and startup. That's where you're verifying what was designed and validating that things are going to operate as they should. Yeah, so that will now overlay complexity on top of that and just see what that simple life cycle helps us to see. So starting with structural, so those aspects of what you're doing along that project life cycle, the design phase, the interfaces with approval agencies, that would drive a bit of a spike in complexity, the risk from complexity on that project. In the construction phase, you'd have things like the number of interrelated tasks that you're trying to manage. In that commissioning phase, you'd have a lot of external stakeholders that you'd be looking to manage as well. So that would create a trend of that risk from complexity that might look something like this. Technical would look a little bit different. So complexity coming from the need to support discovery while maintaining a schedule, the secondary impacts of scope changes, and ambiguity around alternative options would create a different risk profile of complexity on this project. Directional, so that's from leadership impacting the project team forming processes, identities, behaviors of key personnel, and their ability to react to challenges, tensions between desires for innovation and minimizing risks in delivery. And that process time, so that's the robustness of change management processes, the agility of the project team, the structure of the protocol, decision rights that are in place, and external factors, like, as I said, COVID-19 or change of law that might be impacting that project. So just from all of that, key takeaways around that structuring and of that complexity. So number one, complexity is not a single characteristic of a project. Breaking it down into these 4 attributes really does help identify controls that may have failed or competencies that you need to build up. It's a dynamic attribute that ebbs and flows over time. So that's important because no project ever goes according to plan. A baseline really does help recognize how factors might impact the project. And aligning project governance and oversight efforts to this rhythm will help their effectiveness. So many projects have a predetermined team at time of tender that is supposed to manage everything that happens in delivery, and governance controls in these complex environments really need to become more agile and dynamically respond to the environment. So with that understanding, the next is to look at that business response. So this is my sort of simplistic way of the steps to form a response to complexity that a business might take. So first, you need to create a sensitivity to complexity. That gives you situational awareness. And that might mean creating additional information, different metrics that you need to start reporting. You'll need to have an interpretation of those metrics, and you'll need to be able to have some projection scenarios, some idea of how those things will start impacting, the forecast that you might have. In this space, you need to be careful about something called attention tunneling. In complex situations, teams can get too focused on certain information. And there's a really good example of this where, many of you might have seen, there's a video of people bouncing a ball, and you're asked to count the numbers, and you miss the fact that a gorilla has walked through the scene. And that's an example of attention tunneling. A lot of, famous airplane crashes have happened because of this as well. You also need to be careful of data overload from rapid change. Teams get further and further behind information becomes less and less current, creating a downward spiral. So next is the importance of data. So that's been a big part of my journey. And what that means is, governance, data quality, metadata are all things that are going to become much more ingrained into project management, portfolio management in the future. Again, just all those things we talked about, all those, whether we're using blockchain or GIS, different technologies, they all rely on data. So governance, that is the deliberate planning for good data, and it requires setting of standards and procedures specifically around how data is managed in an organization. Data quality, so that's the fitness for purpose of data. So this entails things like accuracy, completeness, consistency, accessibility, compliance, and efficiency. And metadata, if you haven't heard that term, that's information about the data. So things like where it came from, what it relates to, how it was modified, whether it's confidential, etc. So from there, you need to identify an approach that the business is going to take. And that'll depend on things like what kind of decision bureaucracy is in place, the maturity of the systems and procedures. And what I mean by portfolio aspects is, are you looking at risk positions in the business? Is that what the business does? Or are you on a schedule of rates where, it's a different risk profile? Next thing you need to do is match that team capability to the environment that they're working in. And that gap or that stretch that's placed on a team, that is the risk that complexity creates. So the example I like to use is, somebody who's competent to drive a car does not mean that they could drive through the CBD of Sydney at 200 kilometers an hour. That's just the complexity involved just means that that's not viable. And that will get you into a way of getting to the tactics of reacting to complexity. So coming back to, structural complexity, this may include, reviews of team sizes, how activities are grouped, how knowledge is managed. If it's technical complexity, the tactics might include things like design prototyping, iteration controls, or revisiting the design planning process. For directional complexity, this might be an executive steward or a PMO that's helped to support the team. Process or time related, this may involve focusing on missing information and then trying to confine the impact that this has on a project. So again, it's combinations of business, project, and how it's reacting to the environment that it's in. So just as I mentioned, decision timing. So especially when we're dealing with complexity, this is very relevant. You need to be very aware of making decisions too early or too late. So too early, usually that's, everybody has this, it's the desire for immediate action, but it's the too many unknowns that exist. And that usually results in the overuse of committees, decision rights, things just spin until usually you get to the point where it's too late. And businesses that sort of run on that too late, that's usually driven from a culture of rewarding that last minute heroic effort. The issues that it creates a continual firefighting environment. And what really happens is that you're reducing the effectiveness of planning activities. So especially in complex situations, you need to be aware of when you're making decisions. So sort of bringing that all together, what we've just sort of gone through, breaking complexity into 4 characteristics really helps recognize and react to it. Complexity does ebb and flow, so it must be continually assessed. A lot of, my experience with executives, people want to know whether they're signing something off, whether it's a complex project. Well, whether it is or not at one point in time does not mean whether it is or not at another point in time. A risk trend can be created based on planned activities in the environmental context, and enterprise tactics can be put in place to help manage that complexity. And that's what I think we need to start doing. So some final thoughts for me on this. First, complex outcomes are hard to produce, so you need to plan appropriately. So too often financial stretch targets results in, redlining through budget items for training, front-end planning, and when you're dealing with complexity, that's you do that at your peril. The focus needs to shift from driving outcomes to creating the conditions for good outcomes. So the analogy I like to use here is executives need to become, or project directors especially, like a gardener, somebody who enables things to grow on their own. We need to become aware of new biases around complexity. And the big one here is everybody has a bias towards a simple story. And in a complex environment, that can actually blind you from the real situation that you're facing. So you really need to be careful of that. We need to move beyond a hierarchy of bosses to a more agile structure, just to be able to react to the speed of and the velocity of risks that projects are facing these days in these complex environments. And we need to elevate data management. So I don't have an IT background, but through this journey that I've been on, that really has been a primary focus that I've really come to realize. In any situation that you're stepping into, one of the key questions you've got to ask is how reliable is the data that I'm looking at, and that goes into those key aspects that I've been talking through. And the fact is that if you're doing it sort of in a crisis, you're asking those questions way too late. So that is an overview summary of the journey that, as I said, I've been on in this with my investigation into complexity. And then I've just thrown in some further reading for anybody who is interested in this topic. These are sources of that I found pretty good in my journey. So I think this is going to be something that people have access to. So I thought I'd throw that in there. So that's it. Happy to answer questions at this time. Hopefully that was entertaining for everybody. So I'll stop sharing.
Thank you, Matthew. Yeah, we have one question in the chat box. It says, what is the difference between unknowns and unknown unknowns from the Cinefin framework? You showed us a slide, and you show us that there are some known unknowns. Probably that is the question.
Yep. So yeah, so unknown unknowns are things that exist that we do not know about. So the fact that a pandemic was gonna hit us was an unknown, but was it unknowable? I think it there was prior experience where you could have said that it is in the realm of a possibility that we could know that, or have a sense that it is a risk that could hit us, which is that unknowable unknown. So that is the true that is the true black swan event that hasn't happened before, that it's very difficult to plan for.
Okay, and then I will add a follow-up question to the, and since this is an unknown, completely unknown, how can it be an emergent practice? Because we saw in the slide that is an emergent practice. What kind of practices are being applied to them?
Yeah, so so there are lots of unknown unknowns, and that's why I was saying that it's not an attribute that you can identify with a project, especially at an early point in time. It is something that ebbs and flows through a project, but through breaking it down into aspects of it and understanding the types of activities that are going to happen through a typical project, and then relating that to the real environment and the context that you have, that is where I think you can make assumptions and create a risk profile. Again, risks are unknowns to a degree, of things that could happen, could impact a project, could impact the project outcome. But so it's something that you can start preparing for and try to mitigate or reduce the impact when it does happen. But it is something that you need to be aware of. And again, in my journey, it does come back to that source of data and the good data practices. So having access to that data and having that visibility of what I call a data pipeline, you can react and have a good awareness and sensitivity to complexity as it's coming in the project environment.
Okay, thank you, Matthew, for the explanation. We have a couple of questions here. Do you think we should have a different approach to complexity for different sectors in construction?
So definitely it has to, there are unique circumstances that will apply to complexity and create different tactics will be needed. One of the worst things you can do is offer up the right tool, but at the wrong situation, you won't get the right result. So you need to be aware of that. But again, as that it's an emergent nature of complexity and you're not sure what risks you will face, you need to have a simplified or a baseline view and controls that you can have, in line, that you can identify the uniqueness of the situation you're facing and react to it. Because if you're trying to do everything all at once, I think it's too big of a task. So I do think that to some degree, different sectors and so on will have unique tactics that they'll have at the ready. But to another degree, some of those things can be not standardized, but can be common.
Okay. And then Saleh is asking us, would you do this complexity assessment for a project at its start or keep reassessing its complexity frequently?
The answer is yes to both. So, as you're going through and building up an estimate for something that you're going to bid, you can have an idea of some of those things that will happen. And then as you kick off a project, you need to assess, again, do I have the people that I said I was going to have at time of tender, or are they not available to me? So the team will be a little bit different. They need to be assessed as well. And then at key points through a project, and likely through each one of those 4 aspects of complexity, you need to reassess at certain different points in time. So, as a design gets to, maybe a 20 or 30% complete, you may want to have a good look at how you're managing technical complexity and whether things are running away from the project team or not. So you do need to keep going through it.
Good. Robert is asking us, how many people in particular executive understand or appreciate complexity?
I think more and more. So, in my journey, this was coming up as a root cause of poor project performance. So when you have, lots of zeros on a page that, you've left behind on a project, that usually gets executives' attention. And so if that's the reason, that's how I started this journey. You start digging into it and you want to make sure that that doesn't happen again. So I think it is an emerging field. And again, the projects, the sizes of capital projects are getting larger and larger. And there's lots of stories in the news with poor performance and lots of losses. So I think there is a scramble to understand this area better and put controls.
Okay. We're having another question. How to solve complexity which come from external party and it is beyond our power, like politic situations, war damages, etc.
Yeah, so that is that temporal or process type of complexity. And it's, as I said, it will depend on the particularities, but it could be, if you're trying to plan out how your project is going to proceed, again, you need to break it into, well, what do we know are the key risks and what, could be these unknown unknowns? Do we have any indications of them? And in that situation, a lot of tactics would probably relate to, well, what is the missing piece of information that you don't know? So whether it's whether a vaccine will come for COVID-19, for example, well, that piece of information you can then say, well, how do I minimize the impact that information that I don't have will have on my project? And again, it is unique to each situation, but that kind of analysis will help a project manage that type of complexity.
Alberto is commenting, don't you think one of the problems is to assume that we don't need risk assessment or complexity approach to small projects?
Well, that's one of the things that I run into a lot. So people think a small project can't be complex, but that size of project is really just one aspect of complexity. You can have a small project that has, a lot of very unique, without precedent design challenges, and those things combined with, say, a tight time frame can create a very complex environment. You know, it is a different environment from that large scale project that, you know, you could have done. If you're building, I don't know, a school, you could have done 50 schools. You know how to do it. It's you know, something that you're an expert at. So size may not actually just create complexity. It can be combinations of these things.
Fanny is asking us, how can we measure the level of complexity of projects at the initial stage?
So a measurement is, you know, if you're trying to get to a number, you need, again, to break it into those components to get a much better grasp on it. You can put indicators in. As far as a tight measure, a number, that's where you know, that's what a lot of people want. I want to have comfort that I know that this is a 7.2 project and not a 6.4 project. Having that level of degree of certainty in the amount of complexity, again, because it is something that ebbs and flows over a project, is difficult to do. But obviously you can have a comparative metric. And usually that's really beneficial when you're talking about what kind of projects you're benchmarking that project against. So as you're building a project up in that estimate at that early stage, and you've benchmarked it against these others, you can get a sense of what are the activities, what's the environment, who is the client, all those aspects, and how would it be more or less complex than the one that I'm benchmarking my project to from a cost basis or a time basis.
Paul is asking us, do you write a formal complexity management plan? And do you have a regular complexity management meetings?
So my suggestion that is it really should get ingrained into risk management, but it should step risk management up, and it should be integrated into the project controls. Having it sitting off to the side usually lets it be isolated, and that's when things get missed. The other side of that is, you know, depending how the business response, you know, the approach that business has taken, a lot of businesses or people that I've spoken to in the industry, they're not prepared to spend or invest into having so many people trained up in the space. It's usually a small central team, and you need to rely on indicators and, again, you know, data coming from the projects to pick up times where you can parachute in an expert, and then help the team set up some key processes, and then step away and help another project. So you can leverage some central resources to really create a larger effect for the bang for buck, as they say.
Thank you, Matthew. Another question, can we consider all mega projects as complex projects?
I think it's a pretty safe assumption. Mega projects, just the size, you know, you're usually dealing with so many authorities, so many stakeholders. It's a pretty safe assumption that mega projects are all complex projects. It then goes to, well, how do you want to integrate the approach to complexity for that project? Typically, mega projects don't take advantage of a lot of the structures in place around the business that's actually won that job. They usually report directly up to a board, or they're usually in a joint venture to try and help you know, manage some of the financial risk. And so they don't get to take advantage of a lot of the structures that a business unit might have. And so that's something that I think needs to be considered for mega projects.
Great. Salma is asking, if you assess as a complex project at the tender stage, you need to budget at tender stage to allow for the required specialists to assist the project team.
Especially if you identify that it is a more complex project than you may have done in the past, again, compared to what you're benchmarking this against, that's where it would be a good indicator that, yes, you should probably, it would be a good investment to have some of that specialist or some expertise ready, to make sure that, you know, it doesn't, it's probably worth its weight in gold, as they say, to have that specialized expertise to help mitigate the risk for that.
Okay, thank you, Matthew. I don't think we have any other question. Well, I will ask another last question about the digital engineering. You mentioned that it's like getting involved in the complexity assessment. And do you have any example how the digital atmosphere, let's say the geographic information systems, the Internet of Things, and even the machine learning information, how can this affect the complexity of a project, or how can you use this as a tool to evaluate complexity?
Yeah, so that's sort of two questions on either side. So implementing any one of those. So if you're bringing in, machine learning, or, you're doing some, you know, drone surveys to try and, assess progress of a project using photogrammetry instead of, using traditional methods. That in itself creates a change in the project that, can have disastrous impacts across the board, where suddenly you start missing things because they're just blind spots that the technology, has, you're missing that expert who would have picked that up. On the other side, though, using that technology can be significant. I mean, that is what we're seeing with some of these things that are putting in place, these digital twins, is you can get insights that you couldn't get before. So understanding that, when a specific truck comes into the site, there's an increased risk of a safety incident. I mean, those are the kind of things that it'd be difficult to pick up from just a human side of things, but having a large data set and some analytics can actually help with that. So it is a double-edged sword. Done right, it helps reduce the complexity and helps people focus on the job. But before you get to that point, it actually contributes to the complexity that people have to manage.
Well, another last question. Do you think these software engineers or data analysts have some kind of advantage over all the engineering background people that is probably right now in our attendees?
Well, my view of it is, I think the sweet spot for using data and that data analytics and all these digital processes comes when you've got three people that come together in a business. The first is that data scientist, that everybody's trying to figure out, somebody who can write code in Python and really use the data. The second is an architect, somebody who understands the systems and how to connect them all. And the third one, which people overlook, but I believe is the most important, is that business operation side, somebody who understands what the data means that's being fed into this machine. The fact that we're talking about Rio versus formwork versus something else, understanding what these things are and can interpret a lot of that into the machine learning or whatever that digital practice is. Those three things coming together is what I think is where you get the real benefits from it. Anyone on their own, and yeah, I just think you have less of a chance of hitting that key insight.
Good. I think just before finishing, we have asking one last question. Is the project assessment document should include a complexity management plan for future projects?
I think it'd be good to highlight it as as you would a risk, if you see a risk there, or even if you don't see it currently. And having a stop to think about, well, if suddenly the team starts becoming overwhelmed through design changes, or there's a significant commercial issue that's going to be impacting the project and so on, that's going to create complexity in that space. How will we pick it up, and should we stop and pull together a team to assess it, or flag it to somebody else? Having that thought through at the beginning, I think is it's just a good idea. It's better to be prepared and not need it than need it and not have it.
Thank you, Matthew. We don't have any more questions. Well, before to move on to the microphone open session for everyone, I would like to launch a poll and get feedback from our attendees. Please give us your sincere feedback. Just will help us to improve for next webinars.
Well, Matt, I'd just like to take this opportunity to thank you very much for that presentation. It's very enlightening. I must say, when I look at some of the projects I've been involved in the last 40 years, majority of them have been delayed by technology. I remember when I was on the City Link, they didn't have the tolling system running for 6 months while cars were driving up and down. When I was up in Broken Hill, we had a mining project, and the whole thing was delayed by the writing of the software to run the hauling system and the winders, and that was quite interesting. Again, that was flawed by IT. And there's a couple of other projects I know that have been delayed by IT aspects of a project, and typically they're the more complex aspects of civil construction. I think civil construction people need to pay particular attention to what you talked about. Thank you very much for your presentation. I'll hand back to Frank now.
Thank you.
Okay, I think the poll is already completed. Well, from now onwards, we just will encourage everyone to unmute yourselves and start talking and asking general questions of the AACE, or probably keep talking or discussing about complexity in projects. We are going to stop recording right now. And yeah, feel free to unmute yourself.